In this video, we'll be going over how to create this scene, which is of a sun-synchronous orbit spacecraft doing a pass of Los Angeles, San Francisco, and Seattle while pointing its body fixed x-axis towards those targets and at the end tracking its solar panels to the sun. And the scene files for this video will be posted here, CT013, West Coast cities. First, we'll start with the BSP kernel. So if we say brief SSO and cities, we start with the spacecraft, which is the usual -999 SPICE ID. And the three cities here have IDs of 30,000 for Los Angeles, 30,001 for San Francisco, and 30,002 for Seattle. And these IDs are arbitrary numbers where the leading three is for the Earth-Moon system. And these three kernels have asterisks on them because their FEMS data is defined with respect to the IAU Earth reference frame, which is an Earth body fixed frame, since they are stationary with respect to that frame. So in order to calculate their inertial position vectors, as will be done by predict, we will need to load in the PCK00010 SPICE kernel when calling predict. And for reference, the spacecraft in this case is in a 100-degree inclination, which is slightly retrograde, sun-synchronous orbit, and its orbital elements were selected such that it would have this pass of the US West Coast. Here we have the three scripts that we need to use the predict utility. So starting with the meta kernel, here we use a syntax that SPICE understands to be able to set paths to a variable for convenience. So we set the relative path from the directory that this file is in to the SPICE directory of this repository and set that as kernels. And then we can use the kernels variable with a money sign in front of it in the kernels to load definition. And we need to load DE432 to calculate the positions of the Earth and the Sun, the PCK kernel to convert between IAU Earth and EME2000 or J2000 reference frames, and then we have the trajectory data for the sun-synchronous spacecraft, the frame definition, and the city's BSP. The scframe.tf kernel is exactly the same as the last video, where we are giving the spacecraft body fixed reference frame the SPICE ID of -999,000 and giving it the name SC body frame. For the main predict file, we define the nadir and the sun vector directions the same as we did in the last video. And next we define the direction vectors for the cities, where we can see their SPICE IDs of 30,000, 30,001, and 30,002. We define the city pointing orientations to have the primary be the body x-axis pointing at the city and the secondary axis to be the body z, which has the solar panels pointed as close as they can be to the sun vector. And then just like last video, we define the time sequence of the spacecraft attitude, leaving gaps in between the definitions to allow predict to fill them with the attitude slew. Now for the usual catalogs, the SPICE is the same as in the last video with the addition of the cities SPICE kernel. And in the load catalog, we have the new cities.json catalog, which looks the same as the spacecraft catalog, except we define the cities here with their SPICE IDs. And we could have also just put the city definitions inside of the spacecraft catalog, but we split it up here for cleanliness. So that's it for this video, and then the next one, we'll be showing how to add instrument frustums and surface observations to the scenes for scientific instruments visualizations.